The Pearson product moment coefficient of correlation, indicated by small letter r. What is it? It is an index of relationship between two variables. It shows the relationship between the two variables calculated in the same interval or ratio scale. The independent variable can be represented by x, while the dependent variable can be represented by y. Let's say you want to find out if there is a relationship between the number of absences of students and their academic performance. We use Pearson to show the relationship between these two variables. The number of absences will represent the independent variable x, while their corresponding academic performance will represent the independent variable y. The values of correlation coefficient, which is your r, ranges from +1, 0 to -1. Pearson shows relationship in three scenarios. The first one is the positive correlation. If the trend of the line graph is going upward, the value of r is positive. This indicates that as the value of x increases, the value of y also increases. Likewise, if the value of x decreases, the value of y also decreases. Let's say, for example, the relationship between the number of absences of students and in relation to their academic performance. So when the value of your r is positive, it means that when the number of absences is higher, then the academic performance of the students is also higher. If the number of absences of the students is lower, then the academic performance of the students is lower. That's it if your r is positive. The second scenario in Pearson is the negative correlation. If the trend of the line graph is going downward, the value of r is negative. This indicates that as the value of x increases, the value of y decreases. Likewise, if the value of x decreases, the value of y increases. There is an alternate result between your two variables. Let's say, for example, the number of absences of students in relation to their academic performance. When you compute for the value of the correlation r and the result is negative, this means that if the number of absences of students is higher, then their academic performance is lower. While if the number of absences of the students is lower, it means that their academic performance is higher. The third scenario for Pearson is the no correlation. If the trend of the line graph cannot be established either upward or downward, then r is equal to 0. This indicates that there is no correlation between the x and y variables. Let's say, for example, the relationship between the number of absences of students and their academic performance. If the computed value of r is equal to 0, it means that the number of absences of the students has nothing to do with their corresponding academic performances or grades. Now, the decision rule for Pearson is if the r computed value is beyond the critical value, we reject the null hypothesis and accept the alternative hypothesis. In a graph, we see the rejection region and the acceptance region from our critical value. The red line in the graph represents the critical value, and the orange colored that lies beyond it represents the rejection region for your null hypothesis. If in any case your value of r appears beyond the critical value, then you reject the null hypothesis. But if it appears within the acceptance region, then you accept the null hypothesis and then you reject your alternative hypothesis. Now let's get ourselves acquainted with the following terms if we want to statistically treat our data using Pearson. H sub 0 represents the null hypothesis, H sub 1 represents the alternative hypothesis, df represents the degrees of freedom. Now the degree of freedom is important for finding critical values for inferential statistic tests since they relate to the size of the sample. This is the maximum number of logically independent values also, and the values that have the freedom to vary. The Greek letter alpha represents the level of significance. For Pearson, we usually use 0.05 level of significance. Next is our critical value. Critical value is the value in the test statistic which defines the upper and lower bounds of a confidence interval. This will be our basis whether we want to accept or reject our null hypothesis. We're going to use the degrees of freedom and the level of significance to find the critical value of our test. Now, for the critical value, we use the following table in determining the critical values for Pearson. Later on, we will learn how to get our critical value based from this table. The formula in finding the correlation coefficient or the value of R is this one, where R represents the Pearson product moment coefficient of correlation, N is the sample size, sum of xy is the sum of the product of x and y, sum of x, sum of y is the product of the sum of x and the sum of y, sum of x squared is the sum of squares of x, and sum of y squared is the sum of squares of y. Now let's proceed to our example. A study is conducted on the relationship of the number of absences, x, and the grades, that is the y, of 15 students in English. Using R at 0.05 level of significance and the hypothesis that there is no significant relationship between absences and grades of the students in English, determine the relationship using the following data. You have here the data of the 15 students, and the number of absences represents the variable x, and the grades in English represents the variable y. The problem in this study is we want to know if there is a significant relationship between the number of absences and the grades of 15 students in an English class. For the hypothesis, the null hypothesis states that there is no significant relationship between the number of absences and the grades of 15 students in an English class. The alternative hypothesis states that there is a significant relationship between the number of absences and the grades of 15 students in an English class. Here we're going to solve for the value of our correlation coefficient for us to be able to know which hypothesis we should accept and which one should we reject. To start with, let's determine our level of significance, our degree of freedom, and our critical value. The level of significance for Pearson is 0.05. Degree of freedom formula is n minus 2, where n is the number of respondents or sample size. Our n is 15 students minus 2, that is equal to 13. Hence, our critical value is in positive negative 0.514. Now, you might be wondering where we get positive negative 0.514. So, we will be using our level of significance and degree of freedom in order for us to identify our critical value. Now, let's look at the table of the critical value and find positive negative 0.514. On the leftmost corner of our table represents the degree of freedom. The degree of freedom we should find is 13, and the level of significance is on the topmost corner. It's 0.05. Now, to identify our critical value, the area or the value where these two values cross is our critical value for our Pearson R. That's where we get our critical value, positive negative 0.514. Now we already have our critical value, so let's complete this table to be able to solve for the value of our Pearson R. So here the x represents the number of absences and the y represents the data or the academic performance of the students. First thing we need to do is to add the values of x. Find the total, and the sum is 53. So our sum of x is equal to 53. Next, we add all the values of our variable y. So we find the sum, we find the total. The sum is 1201. For the next column, it says there x squared, so we need to square the values of x. So first, 1 squared. 1 squared is equal to 1. Next, 2 squared, it's equal to 4. 2 squared is 4. 3 squared is 9. Another 3 squared is 9. 8 squared is 64. 6 squared is 36. 1 squared is 1. 4 squared is 16. 5 squared is 25. 5 squared is 25. 1 squared is 1. 2 squared is 4. 1 squared is 1. and 9 squared is 81. The next thing that we need to do after we complete this column is to add or find the total of the values in the third column, x squared. So we need to find the sum of x squared. We just have to add all of them, and the sum of x squared is 281. So that is our sum of x squared. Now let's go to the fourth column. It says this y squared. So this time we're going to square the values of y. So first we have 90 squared is 8,100. 85 squared is 7,225. 80 squared is 6,400. 75 squared is 5,625. 80 squared is 6,400. 65 squared is 4,225. 70 squared is 4,900. 95 squared is 9,225. 80 squared is 6,400. 80 squared is 6,400. 75 squared is 5,625. 92 squared is 8,464. 89 squared is 7,921. And 80 squared is 6,400. And 65 squared is 4,225. Next, we can use our calculators and find the sum of the data or the values that are found in the column y squared. So the sum is 97,335. For the last column, it states there xy. So we need to multiply the values of our x and the values of our y. So for the first one, we need to multiply 1 times 90. The answer is 90. Next, 2 times 85. The answer is 170. 2 times 80, it's 160. 3 times 75, 225. 3 times 80, 240. 8 times 65 is 520. 6 times 70 is 420. 1 times 95 is 95. 4 times 80 4 times 80 is 320. 5 times 80 is 400. 5 times 75 is 375. 1 times 92 is 92. 2 times 89 is 178. 1 times 80 is 80. And 9 times 65 is 585. Next, we need to find the total or the sum of the data under xy. So when we add them, the sum is 3,950. Okay. Remember that the value of our n is 15 since we have 15 students being studied. Now, let's remember the values of our sums. So sum of x is 53, sum of y is 1,201, sum of x squared is 281, sum of y squared is 97,335, sum of xy is 3,950, and n is equal to 15. Now we have here the formula for finding the Pearson R. We just need to substitute these values in the formula. So let's start with the first one. Our n is equal to 15, so you have there n is 15 times our sum of xy is 3,950 minus sum of x is 53, sum of y is 1,201. All over square root of n is 15, sum of x squared is 281 minus sum of x is 53, then you square it, times n is 15 times sum of y squared is 97,335 minus sum of y is 1,201, and then you square it. Now let's simplify. 15 times 3,950 is 59,250 minus 53 times 1,201 is 63,653. All over square root of 15 times 281 is 4,215 minus 53 squared is 2,809. 15 times 97,335 is 1,460,025 minus 1,201 squared is 1,442,401. Let's simplify. 59,250 minus 63,650 is negative 4,403. 4,215 minus 2,809 is 1,406 times 1,460,025 minus 1,442,401 is 17,624. Let's simplify further. 1,406 times 17,624 is 24,779,344. So let's simplify. Let's take the square root of 24,779,344. The square root is 4,977.89. We rounded it off to two decimal places. Next, we simplify. Negative 4,403 divided by 4,977.89. The value of our r is at negative 0.885. Do you remember the decision rule? Our decision rule is if the r computed value is beyond the critical value, then we reject the null hypothesis. So here let's try and compare our r value and our critical value. Since our computed r value is negative, then we locate our critical value at negative 0.514. So negative 0.514 is found right over here. And for the rejection region and acceptance region, let's find out if the computed r value lies beyond the critical value, then we reject the null hypothesis. Now let's plot our computed r value. Our computed r value is at negative 0.88. So it lies right about here, over there. So as we can see in our curve, our value of r lies beyond our critical value, which is negative 0.514. Hence, we can say that we should reject our null hypothesis since our value of r lies beyond the critical value. Now for our conclusion and interpretation, we can say the computed value, r value of negative 0.885 lies beyond the critical value of negative 0.514 as 0.05 level of significance with 13 degrees of freedom. So the null hypothesis is rejected. This means that there is a significant relationship between the number of absences and the grades of students in English. Since the values of r is negative, it implies that students who had more absences had lower grades, and students who have lesser absences have higher grades. So that's it for today's lesson. I hope you learned something about Pearson. Always remember, have a statistic amazing day.